This is part 7 of the AWS for Non-Techies course. We explore AWS in the analogy of an office. So, if you've worked in an office, you will understand AWS and why it has the services it does and why it works the way it does. Amazon is often not great at naming their services, so we will shed light on this and make it really easy to understand the concepts. Today, we're going to talk about 5 different databases in AWS. AWS gives us many different ways of storing our data. The simplest one we talked about in part 3, the simple storage service S3. Here, we simply store away files, like on your computer hard drive or on your phone. But why isn't this enough? Why do we need 5 different databases? Let's imagine the following scenario. Your company stores the vacation plan for all employees in an Excel sheet that sits on a network drive. So, Anna from accounting can fill in the days she wants to take off, the same way Hunter from HR does it. This works fine, until both of them want to do it at the same time. Then, Hunter might override the changes Anna made seconds ago, and you can imagine the trouble that ensues. So, in certain use cases, we would like our database to take care of situations like this. And this brings us to ACID databases that follow 4 principles. The first one is atomicity. When we make changes to the database content, we would like it to be all or nothing. That means that when we, for instance, have a database with account balances, and we want to subtract $100 from one account, and our server crashes before we added the $100 to someone else's account, that wouldn't be great. We would have burned $100 due to bad data storage. The second one is consistency. This means that the database has to be in a consistent state before and after every transaction. So when Anna puts in 3 days for a short trip in August, she must subtract the 3 from the cell with her remaining vacation days. The data cannot be saved in an inconsistent state. The third one is isolation. That means that when operations are done in parallel, the result must be the same as if they were executed in sequence. That means when we think of our account balances, if we are processing hundreds of different money transfers per second, that's totally fine if they're all from different accounts. If not, they must be executed in the same order they came in. And the last one is durability. This means that once we have made a change, we can be sure that the data actually stays there, even when the system crashes a millisecond after. If we got confirmation, it has to be saved. Now, databases that follow these 4 principles are often formatted like tables or Excel sheets, if you will. And to get data in and out, the most common language is SQL. It is more or less short statements that tell the database to insert data, update, or select certain rows and columns when you want to read what's in it. Another way of dividing databases is whether they are meant for transaction or analytical processing, also called Online Transaction Processing, or OLTP, and Online Analytical Processing, or OLAP. Our previous examples, the bank account and the employee vacation sheet, required short and simple transaction, so they were typical OLTP use cases. Another one is cases where we have a lot of data and want to do some statistics, so mostly fewer but more complex operations on the data. This could be crunching the sales data from last quarter to get some insight. Okay, that was a lot. Let's put it all back together and see what AWS has on offer for these use cases. So we have OLAP and OLTP on the front and ACID and non-ACID databases on the side. First, we have RDS, the Relational Database Service. It is versatile and supports other typical relational databases like MySQL, SQL Server, or Postgres. RDS is typically used for OLTP ACID workloads, so this could be managing accounts, warehouse inventories, or the like. Second, we have Aurora, which is Amazon's rewrite of the aforementioned databases from other vendors, just more efficient for the most part. Then we have DynamoDB. It is a NoSQL database, so it doesn't use SQL. It can be said to be ACID compliant, but usually it is used as a non-ACID database. Dynamo can be useful for storing posts in the user feed, data from IoT devices, such as your smart thermometer, or the leaderboard of an online game. It is very fast, can handle unlimited amounts of data, if you're willing to pay for it, and is great when you have small bits of data. It is also a key value store. That means your data items have a unique ID and some content. So for instance, a post on Facebook has a unique ID and then content in the form of its text, reference links, the post date, and so on. Next, we have Redshift. Redshift is more of a niche database that is used in larger corporations. Nonetheless, it is important to know for the Cloud Practitioner certification. It is an ACID OLAP database, meaning it is great when you need to do statistical processing on large amounts of data. And lastly, we have Athena. Athena is a really cool concept. Remember our files in S3 buckets? Well, what if we could treat them as a database after all? This is where Athena comes in. It sits on top of your S3 data and can be used to read or query the data in it with SQL. It cannot write any data and therefore is also not ACID compliant. It is great for OLAP purposes when you have the data on S3 already. So that's it for today. I hope I could make this topic understandable. If you want to move on, check out the previous parts in the series and subscribe so you don't miss the next one, or something more advanced here, or a little bit different about ChatGPT. Alright, bye!